Hey everybody, welcome back yet again. We're going to pick up where we left off. If you recall, we've generated a data set with daily stock price data merged together with some macro data, the 3-month T-bill rate and the daily effective federal funds rate from the Federal Reserve Economic Database. We formatted our date variable. Now we're ready to generate some new versions of our variables to go from the levels of the stock price and S&P index to the returns, and then that'll let us run that first capital asset pricing model regression, right? So the commands we're going to use here in Stata are going to be the time series specific lag and difference operator commands. So if you recall, we generated that date variable, and then we set that as our time series identifier, and I would actually suggest swapping that back out and using that TS set command again for trend. That way we're ensuring there's no gaps, and so when we generate these differences and lags, we won't run into any problems. When you go back and try to generate graphs, where you actually want the date to show up, the calendar dates, then you could swap it back out and use the date option. And again, remember what those look like. So the original date variable showed up as that string or text was not readable by Stata, and we formatted into that Stata and human readable date variable here, and then that trend just again is the 1 unit incremental increase per period of time, in this case per day. So the commands we're going to use here, we want to generate the return on Bank of America stock, which is just going to be the percentage change, and it's going to be real easy to do that in Stata. So we're going to use the generate command, and we'll just call this new variable RBAC. So the return on Bank of America stock is going to be equal to the ratio of the difference from one period to the next. So we can refer to that within the command with this difference operator, so D dot BAC, divided by the 1 period lag, so the change from one period to the next, divided by the value last period. So we divide by the lag, L dot BAC. And just to remind ourselves what those values represent, so the lag operator in Stata, again, just refers to the 1 period previous value, the difference, the change from last period to this period, T minus 1 to period T. Okay. And we're going to do the same thing for the S&P. So we're going to generate another new variable, call it RSP, the S&P return, and that's going to be the difference in the index divided by the 1 period lag. And let's go ahead and I just want to take a look. And so our values here, we could go ahead and multiply those through by 100 to give us the percentage point change value. Here we'll leave it in decimal form. And that's going to be fine. So we just take a look at the plot over time for that Bank of America stock return. And it looks a lot like a white noise random variable there. We'll see if there's any predictability. But that looks pretty much like we'd expect to see. So let's go ahead and run that first regression. So the command here, reg, or regress, and it's our individual stock return, RBAC, as a function of the S&P return, so that RSP. And my state is running a little slow here, as always. But once that comes up, we're going to focus in on the CAPM beta, which is just going to be the OLS slope coefficient estimate. Anytime now, there it comes. And that's going to be our value right here. So the fact that it's a little bit greater than 1 tells us that we do have positive covariance between our individual stock and the market as a whole. And we would call this slightly aggressive, right? That value greater than 1 has slightly more volatility than the market as a whole. So that's a good starting point, and we'll be able to look at some more of the time series attributes of our variables as we move forward, but one step at a time. Thanks again, and I'll see you next time.